Alright, we can now run some indexing queries against Elasticsearch using Postman. To do that, first let's create a Elastic Cluster Docker Compose file and run it. So here I added Elastic Cluster YAML file in the Docker Compose folder. I will first briefly discuss the properties in this new Docker Compose file. Here we see that we are using the official Elasticsearch Docker image. Again, we pass the version from the environment file, so we can just update the environment file to include Elasticsearch version. First of all, we have again 3 nodes for Elasticsearch, as was in the Kafka cluster. We have this number again to accomplish quorum and to prevent split brain issue, while maximizing number of nodes, which could be down. It is advised to use odd numbers of master eligible nodes. As with 3 nodes for example, we can have at most 1 node down to construct a network. And also with 4 nodes, we can still have at most 1 node to be down. We can only increase this number with odd numbers of nodes, such as with 5 nodes. With 5 nodes, we can now use 3 nodes to construct a network, and allow 2 nodes to be down while still maintaining a cluster. One more thing here is that, if you use only 2 nodes for example, maximum number of master nodes must be 2. In that case, if 1 node is down, we cannot maintain a cluster. That's why we need at least 3 nodes to maintain a cluster in case 1 node is not running, while also accomplishing quorum. You see that we pass some environment variables here. Node name is a unique name for each node. And cluster name is the name of the cluster, which must be the same for each node. We set discovery seed hosts to the other nodes so that they can find each other. And for master eligible nodes, we specified all 3 nodes that are running. That means any of the nodes can be chosen as the master. This bootstrap memory lock true property is necessary to prevent swapping. Most operating systems try to use as much memory as possible for the file system caches and eagerly swap out unused application memory. This can result in parts of the JVM heap or even its executable pages being swapped out to disk. Swapping is very bad for performance and for node stability, and should be avoided at all costs. It can cause garbage collections to last for minutes instead of milliseconds, and can cause nodes to respond slowly or even to disconnect from the cluster. In a resilient distributed system, it is more effective to let the operating system kill the node. And finally, here we see that we set JVM memory settings, like initial and maximum JVM memory variables setting to 512 MB, which is locally is enough in our case. This ulimits memlock property is also set to give permission to Elasticsearch to be able to lock memory, using the memory lock property we set in the environment section. We also set a volume to make the data persistent after restarting this compose file. And we also set the port as 9200 for only Elastic ONE nodes, which is enough to reach this cluster from outside of containers. Finally, we set the network using the global definition coming from the environment file. Alright, let's run this compose file now. And go to the Postman and check localhost 9200 endpoint. Now we can use this mapping definition to create an index called Twitter-index. Note that we will be using this index in the coming sections, so please create this one on your local Elasticsearch. After creating the index, let's also create an example document using a post request in Postman. Let's now create an Elastic Base module with POM packaging. And create Elastic model, Elastic config, and Elastic Index Client submodules. We will continue with implementation of those modules in the coming lectures. Alright, I will see you in the next section.